It's a sound most of us know all too well, tires whizzing past on concrete freeways. But thousands of residents who live near Valley freeways are experiencing a new, quieter existence thanks to our region's commitment to pave Valley freeways with rubberized asphalt.
Yeah, the impact was almost immediate. We've noticed a tremendous reduction of noise.
Before the rubberized asphalt, it was almost a continuous whoosh of tires on the surface of the freeway, just almost continuous. And that has pretty well disappeared since they put the new surface down.
There was an overnight change. It was very much a big difference.
These residents of the FQ Story Neighborhood Historic District live just a stone's throw from Interstate 10. For many, the freeway is visible from their backyard. Many have been here for years and say their quality of life deteriorated at the same rate freeway volumes increased. Property values also declined.
I mean, we lost a great, big, huge section of our neighborhood for the freeway. So, that alone was quite a shock to the neighborhood and a hardship for the neighborhood to lose a great big swath of the neighborhood itself and all the beautiful homes that went in there.
When we first moved into the house, we're laying in bed and we're hearing this continuous roar. And we thought to ourselves, oh, what do we do here?
We live in a canyon area here with the construction of I-10 freeway and the way the walls are configured. And that whine would bounce off of the walls and just waft over the neighborhood, so it was extreme.
That all changed 5 years ago when the Maricopa Association of Governments, which determines how freeway dollars are spent, designated $34 million to pave 115 miles of Valley freeways with rubberized asphalt. The program was implemented in cooperation with the Arizona Department of Transportation and the Governor's Office. One early champion for rubberizing the new freeway system was Chandler Mayor Boyd Dunn, who insisted that rubberized asphalt be part of the design of the Loop 202 Santan Freeway.
We knew about rubberized asphalt, we knew its potential, and I felt it was a new technology that could be brought into the freeways. We had enormous involvement of neighborhood associations, citizens along the freeway that wanted to design the freeway to be as compatible with their neighborhood as possible. And so I felt very strongly that rubberized asphalt should be part of that freeway.
Rubberized asphalt is a mixture of 20% granulated tire rubber or crumb rubber and 80% liquid asphalt cement, creating an asphalt rubber binder. The binder is mixed together with small stones of uniform size and shape. While most asphalt is about 4 inches thick, rubberized asphalt is poured in a thin layer, only 1 inch thick. The rubber particles help reduce vibration and noise energy.
Whenever the automotive industry is trying to fix a noisy part on an automobile, the first thing they do is put a piece of rubber in between the two components that are making the noise. So likewise, with this material, you have millions of pieces of rubber in between all of the rocks. So as one rock gets hit by the tire, that sound energy is absorbed.
Listen to the difference as this vehicle moves from rubberized asphalt to a concrete surface. Carlson says the difference isn't just in the loudness of the sound, but in the type of frequency produced, going from a high-pitched whine to a lower, more muffled sound.
On concrete or hard materials, it generates a real high-pitched, irritating noise. And in that particular frequency, you can have as much as a 15 decibel reduction in the noise energy.
Elected officials serving on the MAG Transportation Policy Committee and Regional Council quickly recognized that rubberized asphalt was essential in preserving neighborhoods. In developing the 20-year Regional Transportation Plan, local governments committed another $59 million for rubberized asphalt projects. That plan was approved by voters as Proposition 400 in 2004. In addition to repaving some of the noisiest freeway stretches in the region, the plan calls for all new freeways to be surfaced with rubberized asphalt as they are built.
And I think voters saw the benefit of building freeways in the way that be more compatible, especially in the urban environment. Citizens want freeways, but those neighbors or neighborhoods that are living next to freeways really want the freeways to be a good neighbor. And rubberized asphalt has made a real difference.
project by project and really season by season, we're going to do more and more sections using Proposition $400. So that's going to be a big advancement over the next, I'd say, 2 to 3 years.
Ironically, rubberized asphalt was not originally developed for its noise reduction properties. It was first developed by a Phoenix engineer named Charles McDonald to repair potholes through a solution known as rubberized chip seal. When the chip seal proved exceptionally durable, the city began laying the product across the entire roadway to add longer life to the pavement. ADOT then became interested in its use on freeways as a means to reduce pavement cracking.
The primary purpose of using rubber is it's very tough and durable material, but what they like most about it is that it resists cracking. Because you have millions of little pieces of rubber in there, and rubber doesn't crack.
Once they had the right mix, they also learned they needed to apply it at the right temperature.
When we first started experimenting with it, I can remember an inspector calling me up and saying, "It's sticking to our tires, we can't put this stuff down." And that's when we learned that it had to have a higher temperature of application.
Soon, engineers noticed yet another positive feature of rubberized asphalt. It was waterproof and didn't polish like concrete. ADOT soon engineered its use to take advantage of its skid-resistant properties. Watch the difference in water spray as this vehicle goes from standard pavement to rubber pavement. City officials say in the long run, the cost is comparable to regular asphalt pavement.
1 inch of asphalt rubber is about the equivalent of 2 inches of regular asphalt. So while its initial expense on a ton per ton basis is higher, your cost is really lower on a long-term basis because you're putting less down, and it doesn't crack.
There seems to be no end to the benefits of rubberized asphalt. Not only is it quieter and more durable than regular pavement, new research finds it may have air quality benefits as well.
So what we did back in 2004, we have measured the aerosol samples and the PM emissions before the asphalt rubber overlay, and then we came back in 2005 and we measured after the asphalt rubber overlay.
Camille Kalouche is a researcher in the Department of Civil and Environmental Engineering at Arizona State University. He and his team have been studying whether rubberized asphalt reduces tire wear emissions, those microscopic pieces of rubber dust that become airborne as a tire wears. When breathed in, these emissions, known as PM or particulate matter, can enter the lungs and create health problems. To conduct the study, the researchers needed to find a way to trap air emissions so they could measure samples. They found the perfect laboratory in the Deck Park Tunnel.
The tunnel provided the excellent setup in terms of some kind of encased environment. So all the samples we are actually measuring has no other interference from other environmental factors.
First, samples were taken in the tunnel while it still had a concrete surface. After ADOT paved the tunnel with rubberized asphalt, the emissions were measured again.
The study really found that the existing road surfaces that we had previously before the rubberized asphalt produce about 1.5 to 2 times more tire wear emissions comparing to this new rubberized asphalt surface that we have.
The researchers plan to replicate the experiment to confirm their positive findings. And they are also studying whether rubber pavement reduces the heat island effect.
This material, in fact, is a porous material. It has a lot of air void cushions in it. So, in fact, what it can, and it's also a very thin layer. It's about 1 inch or even less sometimes. So having such a thin layer on top will have the benefit of cooling down much faster at nighttime.
One environmental benefit has already been proven. Every lane mile of rubberized asphalt uses about 1,000 recycled tires, for a total of about 10,000 tires for every freeway mile. To date, more than 1 million tires have been spared from Arizona landfills. So what began through the ingenuity of a single Phoenix engineer as a pothole patching product has evolved into a technology that reduces noise, resists cracking and adds life to pavement, makes it safer and more skid resistant, reduces landfill waste, eliminates pollution, and holds promise for reducing the heat island effect. For Valley residents, it all adds up to a better quality of life.
I'm all over the valley a good part of the day, and a lot of freeway driving, and just a lot more pleasant on the chunks of freeway that have the rubberized product.
People stroll along, the sidewalks and enjoy the outdoors with their children and their dogs and that sort of thing. And I don't It's not really a topic of conversation even about the freeway noise being an issue anymore.
In the meantime, engineers from around the world are showing an interest in Arizona's successful rubberized asphalt program.
One advantage of having this on the freeway systems here in Phoenix is that we have over 12 million visitors annually coming out here. And they ride on this stuff and they notice how quiet and smooth it is, and they want to have the same stuff in their hometown.
And while the list of benefits is long, Carlson says ultimately it will be the noise reduction properties that will take this technology around the world. Kelly Taft, Maricopa Association of Governments.